Hi everybody. Here's the first review for the Christmas exam. It's on number sets, intervals, and Pythagorean theorem. Now hopefully when we get through all of this, you will have reviewed all of the topics or at least know what you need to spend some more time on. So true or false are very important because they give us a lot of review on different kinds of topics. So the first one's talking about integers and irrational numbers. Part of what this recalls or requires is that we look at that graph, or at least the set builder, and remember that we have rationals and irrationals inside of the real number system, but only inside of the rationals do we have the integers z and the whole numbers n. So keep that one in mind as we go through the true or false. So the first one says that integers are a subset or part of the irrational numbers, which is not true. It's actually part of the rationals. So that's actually false. This should have been rationals, which would be put as a q. Okay? And yeah, I spelled it wrong. Next, 1 over 4 to the negative 2 is a natural number. Well, remember that 1 over 4 to the negative 2 is really 4 to the 2 on the top, using the happy sad rule, which is just a whole number, which is 16. So yes, it is a natural number. Non-ending and non-repeating numbers are real numbers. Now, non-ending and non-repeating, what does that mean? That would be referring to something like 1.1211211112111112, etc. Okay, it's not ending and it's not repeating. And that is going to be an irrational number, q prime. So it says, are they real numbers? Well, yeah, they are actually, because reals are based on q prime and q together. It's the union of those two sets. So yeah, it's true. It's a real number. Is root 37 rational? Root 37 is a number that doesn't work evenly in square roots. So it would be non-repeating and not ending. So it's an irrational number. It's q prime. Okay. So that means that it's a false statement. That would be irrational. You have to remember the details there. A negative number with an odd exponent will give you a positive result. Negative number with an odd exponent, something like that. Well, if it's got an odd exponent, it's going to give you a negative answer. So that would be a false statement. Question F. Easy mistake that students will make. So this is actually false, because if you were to put negative 0.2 to the exponent 3, that would be 0.2 times 0.2 times 0.2. And that would be an 8 for sure, but it's going to have 3 decimal places. So that would be equal to 0.008 for working that one out. Therefore, it's false. And the last one here, 1.67 is less than 1.67, but that bar notation, the periodic notation, changes the way it works. 1.67 is equal to 1.67676767, but 1.67 with the bar above the 7 only is 1.677777. And so the second number is actually going to be bigger when we hit the thousandths spot. So is it less? The first one is less. That's true. So a quick double check that we've actually done this properly. Integers are part of the rationals, so not irrational. It is a natural number. The non-ending are reals, yes. Is irrational, is not rational, so it's irrational, so that was false. Negative number odd exponent will give a positive, that's false. And the next one's false, and that's true. So as you can see, lots of stuff to review just on that one true to false question. The next one goes a little bit faster because you can use your calculator to help you out with this. 1 divided by 99 is going to give you a repeating decimal of 0.1. So we can just put the bar above it. That's 0.01010101, etc. forever. The next one, 1.912. Now this one is terminating, but you can write it with periodic notation as either 1.912, whoops, not 2 decimals in there, 1.912 repeating zeros, or one that's a little bit more confusing, but you're supposed to understand this, is I could put it as 1.9119 with the 9 repeating forever, and that would give you the same number. And then the last one here is 0.8333, 0.8333, whatever, going on forever. So 1.8333 with the bar. Circle the larger number, number 3, for each of the following pairs. So we have the 46 repeating forever compared with no 46 repeating forever. So it's going to be 2.46464646 dot dot dot. And then the other one would simply be 2.46000000. So the larger number would be the first one. 1.4 or 1.3333 forever. This 1.4 is going to be the larger number. And 1.42857 or 1/7. Now 1/7 is equal to 0.14285714287. And so seeing as it's going to keep on going after that first 7, that's going to be the larger of the two numbers. And yeah, it's a rational number. Okay, it repeats. Circle the irrational numbers in the list below. Let's be sure that we know that pi is irrational, right? That's q prime. Square root of 12, which doesn't work out evenly, so that one is also irrational. Now there is probably one more in this list, and let's try and find it. If you try 4 divided by 13, that's a fraction. Anything that starts off as a fraction is rational. So don't go putting a circle around that. That one's rational. And the repeating decimal is rational. But this one with the repeating, let's see, I got 0.12, 112, 1112, 11112. So this one is going on forever, but not repeating. So that's an irrational number. Now 4/9, square root of 4/9 works out evenly. It's equal to 2/3, so that one's fine. That's a q. And then square root of 3 squared is when you square a square root, you get the same number back. So that one's also q. So hopefully that is clear to you. The next question is asking you to take these numbers and rewrite them as fractions. Now 0.0235, if you plug this into your calculator and you try second PRB, that's the way we convert fractions, decimals to fractions. However, your calculator can't handle the denominator in this number because it's going to have 4 digits. So unfortunately, this trick is not going to work for you. Instead, we have to go back to the old grade 7 method of 235 over 1 followed by 4 zeros because there are 4 decimal places, and then we reduce that by dividing top and bottom by 5. So divide by 5, and you get 47 over 2,000. That's the reduced fraction. The next one, we've got this 235 going on again, but this time it's 0.235 continuing forever, so 0.235353535. And what you do is you plug this number into your calculator, even past the display, and then you use that second PRB notation, and it's going to give you your result, which is 233 over 990. Now you can be absolutely certain that this is true by just dividing 233 divided by 990 to make sure it gives you the right answer. Next question, 1.08 repeating forever is going to be 1.08888888. And just like before, you can plug this into your calculator, repeating off the screen, you go second PRB. Now the answer that it displays is 1/4/45 on your calculator, which is a mixed fraction, 1 and 4 over 45. If the question had asked for a pure fraction, you could either do second ABC to get the conversion from mixed to improper, or you can just multiply 45 times 1 plus 4, get you 49 over 45. Bing! Okay, now we're on the next page, and we're looking at the values that we need to place into the diagram. Remember that n is for integers, is for whole numbers, and z is for integers. So negative 53 is an integer, it's a negative number. 14 is a whole number, goes in there. And do we have any other whole numbers? Well, hiding in here, we have the 6 squared on the bottom, or 6 to the negative 2, which becomes 6 squared on top, which is equal to 36, which is a nice whole number. So 1 over 6 to the negative 2 goes into that circle. So we got those guys taken care of. 3.7 is a rational number, fraction, decimal, and so also the 63 over 100. So they're taken care of. 7.45, regardless of the fact that it's negative, is still going to be an irrational number. So where do we run into difficulties now? 585858. That's what this repeating decimal is all about, and that is also going to be rational because it's repeating. And then the last one is probably irrational, but let's just double check. It doesn't have a repeating pattern, so that's where we're going to put the 0.17111771777 dot dot dot. Good enough? Everything done? Oh, I forgot about pi, and we all know that that is an irrational number. Okay, the next question. This takes a little bit of thinking and careful reading. The grass is in a trapezoid. Okay, so that's the section between the parking lots. The top view is shown, and you're calculating the area of this grass field. Again, remind yourself that that's a trapezoid. Now, some of you guys didn't bother to memorize the formula for trapezoid, and so you might do it as a triangle plus a rectangle. Now, I'm not going to work this question all the way through. You'll have to look at the answer sheet, but I'll just tell you the secret is to get a right triangle in here, and that means that we're going to have the difference of 37 and 22, which is going to give me the 15 for that vertical line, and the unknown part here I'll call A, which is the width of the parking lot. Pythagorean theorem, A squared plus 15 squared is equal to 17 squared. Long story short, A is equal to 8. And remember, you show all your steps along the way. And then the rest of this should go without any complications. Remember, this is measured in meters. And so you make sure you put your units at the end. So your final answer is going to be that the area, and let's write that in a sentence. It reminds you to put the units and to actually answer the question. The area of the parking lot is, and remember that it's a trapezoid, so you have to add the triangle and the rectangle if you didn't use the trapezoid formula. The area of the parking lot is 236 meters squared. Number 8. And then I'll probably pause after this. The two right triangles are placed up against each other, and you're trying to determine the length of sides B and D. There should be an and in between there. Well, look at the first triangle. On the right, where side B is, it is a right isosceles triangle. The B and the B would both be equal to each other, and so you would be solving B squared plus B squared equals 20 squared, which, if you'll remember how we do this, you have to set it up as an equation, and so it's going to be 2b squared is equal to 400. Divide both sides before you square root. B squared is equal to 200, and then you square root both sides to get that B is equal to approximately 14.14 blah blah blah. And in the question, you'll have to look for whether it says what you should round to. In this case, and on your exam, it will probably say round to the nearest hundredth, which is 2 decimal places. So I got the first part, I got the B. Now I need to find the D. Well, I'm going to use this value of 14.14, but please remember that that was calculated as the square root of 200. So that when I'm setting up for the second triangle, the 30 squared plus the B squared, which is 14.14 approximately squared, is equal to D squared. The 30 squared is going to be no problem. It's going to be 900. And the 14.14 squared is going to be 200 exactly, because we're using the exact value from it. And then that's going to be equal to D squared. And working that out, you're going to square root both sides. And D is equal to 33.17. Square meters? No, just meters, and this one here is meters. And watch out, the question may ask you for area, it may ask you for perimeter. Make sure you actually answer the question that's being asked in the example. All right, that's it for now. And like I said, stay tuned to part 2 to see the rest of this review.